all, welcome to Know Physics with me. Hope all are doing good. Yes, so we have already started with Physics CBSE Class 10, Chapter 10, Light, Reflection and Refraction, and we are in the 10th session. So already 9 sessions we have completed based on reflection as well as refraction. So in previous session we saw how we will draw or the rules to draw ray diagram for lenses. Yes, so in this session we will see how image is formed using a ray diagram in case of concave as well as convex lenses. Clear? Yes. So that is what we are going to see in this session. So those who have missed any of the previous session, I will provide you the playlist link in the description box so that you can check to it and watch it. Okay? Yes. So we are going to see image formation in lenses using ray diagrams. Okay. So first of all, we will consider convex lens and then we will go for concave lens. So just like concave mirrors, in convex lens we have 6 different places or positions of object where we are going to place the object and see where image is formed. Okay. So 6 different positions in case of convex lens, whereas we had 6 cases in concave mirrors. Okay. And the same opposite process, that is for convex mirrors we had 2 cases and for concave lens we will have 2 cases. Clear? So before drawing into this, let us plot what all we know. What are all the important terms related to convex lens as well as concave lenses. Okay, basically. So in previous session we saw what are all the important terms related to lenses, and that is how I named this. So here convex lens I have drawn, and the center of the convex lens is nothing but the optic center. We call it as pole in case of mirror. Here we call it as optic center. Okay. And we have 2 focal lengths since we have 2 spherical surfaces. Okay, so F1 and F2, and instead of C we have 2 C's. So in order to differentiate it, because we have 2 center of curvature, center of this pair as well as center of this pair. Okay, so instead of center of curvature we use the term 2F1 and 2F2. Clear? Yes. So those who don't know detail about this, please watch my previous session. Okay. Yes. So convex lens. Similarly, for obtaining an image, we need at least 2 rays. Yes. So out of the 3 rules, you can use any of the 2 rules in order to obtain the image. So it is easy to use the first rule and the third rule. Okay. So yes, what are all the 6 positions? Let us see. We will try to compare it with mirror and learn. So you will find it very easy. So in mirror, what was the first position? At infinity, right? Similarly, in lens also at infinity is our first position. Then second position was beyond C. Yes. So here instead of C we are using 2F1, right? So here we will name it as beyond 2F1. We will place the object and see where the image is formed. Next is at C. So instead of that we use at 2F1. Okay. Then the fourth position is between 2F1 and F1. And the fifth position is at F1. And the sixth position is between F1 and O. Since there it is between P and F, because we consider this as pole. Here it is optic center, so between F and O. Okay. So correctly mention whether it is F1 or F2 exactly. Okay. Yes. So we will directly get into one by one cases. Okay. You try to draw it by yourself also. Once you are thorough with mirrors, drawing ray diagrams for lens is very easy except 1 or 2 conditions. So once you are done with any one position, remaining all you can try it by yourself. Okay. So let us start with first position. So at infinity, as I told you already, at infinity means we will consider only what rays? Parallel rays. Yes or no? So parallel rays. So what is our first rule? A ray parallel to principal axis after refraction passes through the focus on the other side. Yes or no? So a ray parallel to the principal axis after refraction. So here in order to show refraction, how will you denote it? By bending the ray. Yes or no? So after refraction it passes through the focus on the other side of the lens. Clear? So this is how your refracted rays come. So again we have to consider at least 2 for an image formation, at least 2 rays, right? So we will consider one more rays. So a ray parallel to the principal axis after refraction passes through the focus. Okay. where is the image formed? Image is formed at F2. So for a object placed at infinity, you will get the image at F2. So what kind of image you will get? Real and inverted as well as point sized or highly diminished image will be obtained. So what is it? Highly diminished or point sized, you can call it as. Okay, and what type of image you are getting? Real and inverted. Okay, so just like concave mirrors, we will have all the cases real and inverted except for one case, where is between P and F you will have virtual and direct, yes or no, and it is formed on the same side. So this is just quite same as that, that is convex lens cases are quite same as that of concave mirrors. Okay, so here also for all the cases we will have a real and inverted image except for the last one, that is between F and O. In that case we will have virtual and direct image and it is formed on the same side. Clear? Yes. Now we will go with the second case. So try to do it by yourself. So what is the first rule? Array parallel to the principal axis. Now we are going to place the object beyond 2F1. So something like this let us consider. Okay? Yes. So from where you will start the ray? From the tip of this object. Yes. So the tip of this arrow. So array parallel to the principal axis after refraction passes through the focus on the other side. So my diagrams are not perfect. Draw it with ruler. So you'll get a perfect diagram. Okay. And next one. Array passing through optic center. You can either use second rule also, but third rule is very easy. That's why I am using third rule. So array passing through the optic center goes undeviated. Yes or no? So from here array passing through the optic center. So this is, consider this as array passing through the optic center goes undeviated. So your arrow will be just like the same. Okay, it should not be the reverse arrow. So goes undeviated means it should be in the same direction. So where your image is formed? Here, right? So where both the rays meet, there you will have the tip. Okay, so what kind of image is formed? Real and inverted. And where your image is formed? Between F2 and 2F2, and whether it is small size or larger size. When compared to this is of small size. Okay, so diminished image. Okay, here it is not perfect. Try to do it by yourself using scale. That time you will get exact diminished image. Okay, when compared to the size of the object, your image size will be smaller. Okay, so what is the third position? At 2F1 we are going to place. So at 2F1 when you place the object, array parallel to the principal axis. After refraction, it passes through the focus on the other side. Okay. And array passing through the optic center. So array passing through the optic center goes undeviated. So where your image is formed? Exactly at 2F2. So if you draw a perfect diagram, you will get the image formed at 2F2. So it is what kind of image? Real and inverted formed at 2F2, and whether it is smaller in size, same size, or larger in size. So when you see, you will get same size image, okay, as that of object. So this is our third case. So the next case is between 2F1 and F1. Yes. So you will place an object here. Yes. So array parallel to the principal axis after refraction passes through the focus on the other side. Similarly, array passing through the optic center will go undeviated. Okay, so the arrow is like this. So where it will meet at a point beyond 2F2. What kind of image is formed? Real and inverted. Where it is formed? Beyond 2F2. And what type of image you get? Whether it is smaller, larger, or of same size. It is bigger than this, right? So enlarged image you will obtain. Clear? Then we will go with the next case. So at F1 we are going to place. So array parallel to the principal axis after refraction passes through the focus on the other side, then a ray passing through the optic center goes undeviated. So if you see, you will get parallel lines, right? So parallel lines, where they will meet? They will meet at infinity, yes or no? So from infinity only we will draw the parallel lines. So we will assume that lines to meet at infinity. So where the image will be found? At infinity. And then what kind of image you will get? Highly enlarged. And here also it is observed to be real and inverted image. Okay, clear till this? So the last case is between F1 and O. So here we are going to place our object. Okay, so where the image will be found, let us see. A ray parallel to the principal axis after refraction passes through focus on the other side. Then a ray passing through the optic center goes undeviated. Actually it is not parallel lines, it appears to diverge. Okay, so when you see on the other side, it appears to meet somewhere here. Okay, clear? So beyond here only your image appears to meet, I mean the rays appears to meet. So that is where your image is formed, right? So beyond 2F1. So the last particular case, that is between F and O, if you place, what type of image you will get? Virtual and erect, right? Here it is virtual and erect. It is not formed on this side. Instead it is formed on the same side. On same side. On same side. On same side and virtual and erect image. And what type of image you get? You get enlarged image. Yes or no? In previous case you will get highly enlarged image because parallel rays meet at infinity. So infinity we will observe it to be highly enlarged image, and here it is enlarged image. Clear? So when you compare this with concave mirror, you will find all the cases are quite similar except the points. Okay, in that is in mirrors we have reflection, so it will be formed here. Here it is refraction, so it will be formed. Image will be formed on the other side except the last case. Clear? Yes. Now we will go with the concave lens, which is quite similar to that of convex mirror. Okay. In concave lens, we have only two cases to draw the image formation using ray diagrams. Yes. So compare this with convex mirror. So we had only two cases. One is at infinity and a point somewhere between infinity and O. Here, right? There it was between infinity and pole. Here infinity and optic center. Clear? So the rules applies the same here. So a ray, now I am placing somewhere at infinity. Okay. So at infinity means you need not draw the object because you will have what kind of rays? Only the parallel rays, right? So rays parallel to the principal axis. Listen to this carefully. Rays parallel to the principal axis. What it has to do? After passing through the lens, what it has to do? It has to refract, right? So here refraction takes place and it diverges. Yes or no? See, convex lens are converging lens, whereas concave lens are diverging lens. So it diverges. Similarly, rays, we must draw at least two rays, right? So after refraction, it diverges like this. Yes or no? But when you extend this line, you can see it appears to come from this focus. Clear? So what kind of image always you get in concave lens? You always get virtual and erect image. So the point is like this. So the rays parallel to the principal axis in case of concave lens after refraction appear to diverge from the point of focus. Clear? Yes, which is on the same side. So virtual and erect, point sized or highly diminished. And where the image is found? At focus, at F1. Clear? And the second point is where anywhere between infinity and O. So let me keep it as here. Okay? Infinity and O. Anywhere between that point you can keep your object. So a ray parallel to the, so you can draw a little bigger size of your lens. Okay? try to adjust my diagram. You draw a perfect diagram using rulers, you will get the exact position. Okay. So a ray parallel to the principal axis after refraction diverges actually. Yes. And a ray passing through the optic center goes undeviated. Clear? So it appears to come from here. So where your object is obtained, where both the rays meet. Yes or no? So here only your object is obtained. So between infinity and O, if you keep between F1 and O, you will get the image. What kind of image? Virtual and erect diminished image. Sorry, here only you will have the arrow, right? Yes. So diminished image. Clear? So these are all the two cases for concave lens, which is quite similar to that of convex mirror, and convex lens, which is quite similar to that of concave mirror. Clear? So two positions only at infinity and somewhere between infinity and O. Okay. So if you get one, you will get as virtual. Both the cases are virtual and erect as well as diminished. Okay. Here it is point size and highly diminished. Here it is diminished. Here you will obtain the rays to be coming from the point F1. Okay. So it will appear to meet at point F1. Here it appears to form the image or the meet at the point between F1 and O. So the image formed here is virtual and erect, diminished and between F1 and O. Clear? Yes. So I hope you are all clear with both concave and convex lens image formation using ray diagrams. Yes or no? So I think it is quite useful for you to understand, and if you like it, do share it with your friends and do practice these ray diagrams. Then only you will find it easy. Once just seeing the video will not be enough. Okay. So try practicing, and arrow marks are very important for ray diagrams as well as the image formation. That tip you have to indicate it using the arrow mark. That tip where the two rays join, right? That point is where the head of your object, image lies. Okay. Yes. So if you like the video, do share it with your friends. Do subscribe my channel. So thank you for watching this video. Thank you for all the support given. Keep supporting. So thank you.